To determine the appropriate electrical service size for a hotel with 26 air conditioning or heating units, each drawing 14 amps at full load, a specific calculation must be performed. Firstly, calculate the total load by multiplying the number of units by the amperage per unit. In this case, it's 26 units multiplied by 14 amps, which equals 364 amps. Secondly, to determine the required service size, consider safety and future expansion. The National Electrical Code, or NEC, mandates that the minimum service size for a hotel should be 125% of the total load. Therefore, calculate 125% of 364 amps, which equals 455 amps. Based on these calculations, the hotel requires an electrical service size of 455 amps to accommodate the 26 electric units. This ensures that the electrical system can handle the load of all the air conditioning units operating simultaneously, while also providing a margin of safety and capacity for future needs. The NEC requirement to size the service at 125% of the total load is crucial for several reasons. 1. It accounts for the continuous nature of the load. Air conditioning systems, particularly in a hotel setting, are likely to operate for extended periods, making them a continuous load as defined by the NEC. 2. It provides a safety factor to prevent overloading the electrical system. Overloading can lead to overheating, damage to equipment, and potentially even electrical fires. 3. It allows for future expansion. Hotels often add new electrical equipment or appliances over time. Sizing the service with a 25% margin ensures that the electrical system can accommodate these additions without requiring another service upgrade. When upgrading an electrical service, it's important to consider several factors to ensure the new service meets the hotel's current and future needs. These factors include the following. Firstly, conduct a thorough load calculation. This involves identifying all electrical loads in the hotel, including lighting, appliances, HVAC systems, and any other equipment that draws power. Determine the amperage required for each load and sum them to arrive at the total load. Secondly, consult the NEC. The NEC provides detailed guidelines for sizing electrical services, including requirements for conductor ampacity, overcurrent protection, and grounding. Ensure that the new service complies with all applicable NEC requirements. Thirdly, consider future expansion. Estimate the potential for future electrical loads in the hotel. This may include adding new guest rooms, installing new equipment, or upgrading existing systems. Size the new service to accommodate these future loads. Fourthly, select appropriate equipment. Choose electrical equipment that is rated for the voltage and amperage of the new service. This includes the service entrance conductors, overcurrent protection devices, and distribution panels. Fifthly, engage a qualified electrical contractor. Upgrading an electrical service is a complex and potentially dangerous task. It should only be performed by a licensed and experienced electrical contractor who is familiar with the NEC and local electrical codes. The electrical contractor can assist with load calculation, equipment selection, and installation of the new service. In addition to the NEC requirements, local electrical codes may also apply. These codes may impose additional requirements or restrictions on the installation of electrical services. It's important to consult with the local electrical inspector to ensure that the new service complies with all applicable codes. Once the new service is installed, it's important to maintain it properly to ensure its safe and reliable operation. This includes regularly inspecting the equipment for signs of damage or wear, testing the overcurrent protection devices, and keeping the area around the service entrance clear of obstructions. Here's a more detailed breakdown of the factors involved in calculating the electrical service size. Firstly, calculate the total connected load. This is the sum of the amperage ratings of all electrical equipment in a hotel. Include all lighting, appliances, HVAC systems, and other electrical loads. Secondly, determine the demand factor. The demand factor is the percentage of the total connected load that is likely to be in use at any given time. This factor varies depending on the type of occupancy and the nature of the electrical loads. For a hotel, the demand factor for lighting and appliances is typically around 50 to 60%, while the demand factor for HVAC systems is typically around 75 to 85%. Thirdly, calculate the maximum demand. Multiply the total connected load by the demand factor to determine the maximum demand. This is the maximum amount of power that a hotel is likely to draw at any given time. Fourthly, apply the NEC 125% rule. As mentioned earlier, the NEC requires that the service size be at least 125% of the maximum demand. This provides a safety factor and allows for future expansion. Fifthly, consider other factors. In addition to the maximum demand and the NEC 125% rule, other factors may also need to be considered when sizing the electrical service. These factors include the voltage of the service, the type of overcurrent protection devices, and the length of the service entrance conductors. The voltage of the service will affect the amperage rating of the conductors and overcurrent protection devices. Higher voltage services require lower amperage ratings. The type of overcurrent protection devices will affect the interrupting rating of the service. The interrupting rating is the maximum amount of current that the overcurrent protection devices can safely interrupt. The length of the service entrance conductors will affect the voltage drop in the service. Voltage drop is the decrease in voltage that occurs as electricity flows through a conductor. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. When selecting equipment for the new service, it's important to choose equipment that is rated for the voltage, amperage, and interrupting rating of the service. It's also important to choose conductors that are sized appropriately to minimize voltage drop. Here are some additional considerations for upgrading the electrical service in a hotel. Firstly, coordinate with the utility company. The utility company will need to approve the service upgrade and may have specific requirements for the installation. Secondly, obtain necessary permits. A permit is typically required to upgrade an electrical service. The permit ensures that the work is performed in accordance with local electrical codes. Thirdly, schedule the work carefully. Upgrading an electrical service can disrupt the hotel's operations. It's important to schedule the work carefully to minimize disruption. Fourthly, notify guests. Guests should be notified in advance of the service upgrade. This will give them time to make alternative arrangements if necessary. Fifthly, provide temporary power. If possible, provide temporary power to the hotel during the service upgrade. This will allow guests to continue using essential electrical services. Sixthly, inspect the work. Once the service upgrade is complete, inspect the work to ensure that it has been performed correctly. This will help to prevent problems in the future. Proper grounding is also crucial for the safe and reliable operation of an electrical system. Grounding provides a low resistance path for fault current to flow back to the source, which helps to trap the overcurrent protection devices and prevent electrical shock. The NEC specifies detailed requirements for grounding electrical systems. These requirements include the use of grounding electrodes, grounding conductors, and bonding jumpers. Grounding electrodes are typically metal rods or plates that are buried in the earth. They provide a connection to the earth, which helps to dissipate fault current. Grounding conductors are wires that connect the grounding electrodes to the electrical system. They provide a path for fault current to flow back to the source. Bonding jumpers are wires that connect different metal parts of the electrical system together. They help to ensure that all metal parts are at the same electrical potential, which reduces the risk of electrical shock. When upgrading an electrical service, it's important to ensure that the grounding system is properly installed and maintained. This will help to protect people from electrical shock and prevent damage to equipment. In addition to grounding, surge protection is also important for protecting electrical equipment from damage caused by voltage surges. Voltage surges are brief spikes in voltage that can occur due to lightning strikes, power outages, or other electrical disturbances. These surges can damage sensitive electronic equipment, such as computers, televisions, and appliances. Surge protection devices, or SPDs, are designed to protect electrical equipment from voltage surges. SPD work by diverting the surge current to ground, which prevents it from reaching the protected equipment. SPD are available in a variety of types and sizes. They can be installed at the service entrance, at distribution panels, or at individual outlets. When upgrading an electrical service, it's important to consider installing SPD to protect the hotel's electrical equipment from voltage surges. The cost of upgrading an electrical service can vary depending on the size of the service, the complexity of the installation, and the local labor rates. However, it's important to remember that upgrading an electrical service is an investment in the safety and reliability of the hotel's electrical system. A properly sized and installed electrical service can help to prevent electrical fires, protect equipment from damage, and ensure that the hotel can meet its current and future electrical needs. Here is a step-by-step guide to upgrading an electrical service. Firstly, assess the existing electrical system. Determine the size of the existing service and the amperage ratings of the conductors and overcurrent protection devices. Identify any existing electrical loads that need to be upgraded or replaced. Secondly, calculate the new electrical load. Determine the total connected load of all electrical equipment in the hotel. Apply the appropriate demand factors to calculate the maximum demand. Thirdly, determine the required service size. Multiply the maximum demand by 1.25 to determine the required service size. Consider other factors such as the voltage of the service, the type of overcurrent protection devices, and the length of the service entrance conductors. Fourthly, select appropriate equipment. Choose electrical equipment that is rated for the voltage, amperage, and interrupting rating of the new service. Choose conductors that are sized appropriately to minimize voltage drop. Fifthly, obtain necessary permits. Apply for a permit to upgrade the electrical service. The permit will ensure that the work is performed in accordance with local electrical codes. Sixthly, coordinate with the utility company. Contact the utility company to schedule the service upgrade. The utility company may have specific requirements for the installation. Seventhly, install the new service. Disconnect the existing service and install the new service in accordance with the NEC and local electrical codes. Eighthly, inspect the work. Once the service upgrade is complete, inspect the work to ensure that it has been performed correctly. Ninthly, test the system. Test the new service to ensure that it is operating properly. The testing should include checking the voltage, amperage, and grounding system. Remember to consult with a qualified electrical contractor throughout the process. Their expertise is invaluable in ensuring a safe and compliant installation. Furthermore, consider the long-term implications of your electrical upgrade. Investing in energy-efficient equipment and practices can reduce the hotel's energy consumption and lower its operating costs. This could include upgrading to LED lighting, installing energy-efficient HVAC systems, and implementing a building automation system to optimize energy usage. By taking these steps, the hotel can not only ensure a reliable and safe electrical system, but also reduce its environmental impact and improve its bottom line. Consider consulting with an energy efficiency expert to identify potential energy-saving opportunities. They can conduct an energy audit of the hotel and recommend strategies to reduce energy consumption. These strategies may include improving insulation, sealing air leaks, and optimizing the operation of HVAC systems. In addition to energy efficiency, also consider the potential for renewable energy sources. Solar panels can be installed on the roof of the hotel to generate electricity. This can reduce the hotel's reliance on the grid and lower its energy costs. Other renewable energy options include wind turbines and geothermal systems. The feasibility of these options will depend on the location of the hotel and the availability of resources. Upgrading the electrical service is a significant investment, but it is an investment that can pay off in the long run. By carefully planning the upgrade, selecting appropriate equipment, and implementing energy-efficient practices, the hotel can ensure a safe, reliable, and cost-effective electrical system.